trig functions expressed as acute trig functions. To understand this, you need to have a pretty good basic of a lot of the trig stuff before this. And one of the more important things is remembering are all students take calculus, the signs of the various quadrants and things like that. I'm just going to bring the calculator up to help me here, especially for the signs. Now you're going to see some of these in degrees and some of these in radians, and what you could do for the radian ones is, of course, convert them to degrees by multiplying them by 180 over pi. But what you're going to see me do is actually just leave them in radians, and I'm going to talk about that when I get to that last example. But the first example here is sine 100. Now sine 100, if you were to draw that angle, it would be in the second quadrant. It would look something like that. It's between, it's more than 90, less than 180, and so on. So that's sine 100. And the first thing you need to do is determine the quadrant, which we already did. That is quadrant 2. And the reason why that's so helpful is because you need to know if this is positive or negative. And so we look to our ASTC and we see that in quadrant 2 sine is positive. So I'm going to write it as positive sine. Because in quadrants 3 and 4, sine is negative. Now, there's another way for me to figure that out, other than remembering all students take calculus, is if I type in sine 100 into my calculator, it's going to give me a a positive decimal, which really is a positive ratio. But it's positive, and that's how I can tell that it's positive. But the reason it's positive is because in quadrant 2, when I turn this into my triangle, and, I do opposite, adjacent, and hypotenuse. Sine is opposite over hypotenuse, and that is a positive number. That's a positive number, so sine's a positive function in quadrant 2. Cosine, of course, in this quadrant would be negative because the adjacent there is negative. But anyways, the first thing you want to do is figure out what quadrant you're in, which allows you to determine if you should put a plus or a negative in front of your function. In this case, a positive sign in front of sine, and the calculator can also assist you with that. The second thing you need to do, and the last thing really you need to do, is remember your rules for the reference angles. That in quadrant 2, we do 180 minus theta. In quadrant 3, you do theta minus 180. And in 4, you do 360 minus theta. Because we're trying to reference these as acute trig functions. This is why we learned, reference angles, quadrant cousins. So in quadrant 2, we do 180 minus the angle, and 180 minus 100 is 80. Just stick with the same color. Sine 80. And so that's my final answer. We're going to get to the point where we actually convert that to an exact value ratio, but for now we're just trying to convert it to an acute angle. And very easy to check that I typed sine 100 in here. Well, now let me type in, positive sine 80, my answer. I don't need to type anything for the positive because when you don't put something, it's positive. So that's positive sine 80. And I see that they match. They're the same thing. So it's really easy to check your answers here to know you're right. So you should always check your work. All right, second example. Cosecant 250. If I draw this angle, 250, that is going to be in quadrant 3. It's more than 180. It's less than 270. So that's my quadrant 3 version of 250. And so that's the first thing I established, is I'm in quadrant 3. And I'm working with cosecant. So now I need to kind of ask myself, is cosecant positive or negative in quadrant 3? The ways of figuring that out are using ASTC. All students take calculus, recognizing that in quadrant 3, only tangent and cotangent are positive. So this is going to be a negative function, a negative cosecant. And the other way is my calculator can confirm this, that the way I type in cosecant, first of all, is 1 divided by sine, because we don't have a cosecant button, but we know cosecant's a reciprocal of sine. So 1 divided by sine 250 is how I type in cosecant, and I see it's negative 1.06. The 1.06 isn't important right now. The fact that it's negative confirms to me that I should put a negative sign in front of cosecant. Then I use my reference angle rules. In quadrant 3, we do your angle minus 180. So 250 minus 180 is 70. And so that's my answer. I can confirm it by doing 1 divided by negative sine. It's important you do that. Negative sine 70. And I see it matches my original answer, so I know I'm correct. One more example. last one is cotangent 11 pi over 6. First of all, what quadrant are we in? It's a little tricky in radians, so you have to think about it a little bit. But remember, it's over 6. So 180 would be 6 pi over 6, and 360 would be 12 pi over 6. And I see I'm just short of that at 11 pi over 6. So that's how I know I'm in quadrant 4. And so I'm in quadrant 4. And I could type cotangent 11 pi over 6 into my calculator, but I'd have to put the setting on radians first, which is not a problem. Or, of course, I could convert to degrees and then go from there. We know it is quadrant 4 because it's just short of 12 pi over 6. And in this quadrant, only cosine and secant are positive, so cotangent is going to be negative. Negative cotangent, and the reference angles for something like 11 pi over 6 is simply 1 pi over 6, which is a little bit easier, in my opinion, than working with degrees.